Hey kiddos, this is lesson 11, defining reflections. So our learning goal is let's reflect some figures. So if you think of reflections, you can always think about looking yourself in the mirror, right? You see your reflection. If you look at our warm-up, 11.1, which one does not belong? Crossing the lines. So which one do you think does not belong? There's so many different ways we can answer this, correct? Now, if you're thinking about reflections, um, what do we notice about the distance between line L and the 2 points with this one and this one with C to C prime, and then A to B for figure 4? What does figure 2 have a difference of, right? And then also, if you notice with this reflection, figure 1, it doesn't look like the rest of them, does it? There's something different. So what's the difference between figure 3 and everyone else? Perhaps just labeling, right? Figure 4, what's the difference? Maybe just A to B. I don't see anything else. All right, so figure 1 looks like it's slanted here. All right, it's different than all the others in that sense. Figure 2, the distance between the line of reflection, line L, is not the same. From A to the line of reflection is 4, and then the distance from B to the line of reflection is 6. That's different than all the other figures. Figure 3, perhaps C to C prime. That's the only thing I really notice. If you see anything else, let me know. And figure 4, A to B, looks relatively same. Another thing to note is these little markings here, right? The figure 2 doesn't have any of those markings. It just says 4, it just says 6. So is 7 right here in the middle of this distance between A to the line of reflection? Just like the 5's here, and the 5's up here in figure 2, and I'm sorry, figure 1 and figure 3. It's a lot going on there. All right, so for right now, we're going to do this one probably together in class. So this is an info gap where we study certain problem cards given certain data. We're going to have to go over that in class in the beginning just to kind of discuss the scenarios here, because there's 2 different scenarios and I actually have to draw on this just to kind of make sense of it. All right, so we're going to do this one in class. All right, activity 11.3, triangle in the mirror. So Karan started reflecting a triangle CDE across line M. So far he knows the image of D is D prime and the image of E is E prime. So this kid knows that D is right over here. And now, after you do some reflection across line M here, the new image is D prime. So it goes from D and then it reflects across to give us D prime, as well as E reflecting over line M, giving us E prime. It says use the tool below, annotate the diagram to show how he reflected point D. Well, let's figure that out. Let's see. I'm just going to use a line segment here. From D to D prime, but how did he get there? So let's see. What kind of line is D to D prime to line M? What do you think that looks like from previous lessons? Hopefully you realize that looks like a perpendicular bisector. How do we construct perpendicular bisectors? Well, we need circles, yeah? So let's see. Has to be on the line, right? So maybe this kid created a circle there on the compass, right? Creates another one, same size, right? Actually, let's not use that circle. Let's use this one. One sec. I'm trying to figure this out. Where should we put the circles? Okay, so we had from circle D here to circle, or to the line. What if we do same size circle here to here? Do you see how I did that? So if you notice, could have probably done that. The distance between D to the line of M is the same because of the radius, right, of the second circle. So out here, could have done that. What else could we have done? It's a perpendicular bisector, right? So we needed a perpendicular bisector still. So what if we created two circles on the line of reflection? So we got this one from here to here. And then we would have to create another circle of the same size. Not quite the same size. Oh, that's why. Our center is not on the line. So you could have done that. You could have created two compass circles, right? And their points of intersection would give you the perpendicular bisector across to get you D prime. So perpendicular bisectors and constructing them is still very important. Gotta know how to do those. All right, let's see. Number 2, use a straight edge and compass moves to determine the location of C prime. Then shade CDE. So what about C, point C? So let me clean this up a bit. So for C, let's do another line of, or let's do another compass construction from line M to C. And let's not use that one, let's use the compass. We want this circle to have the same radius as the other one, but we need to move from here to here. Do you see it? Let's use our perpendicular bisector. And there you go. C prime would be right there. And if we created our new image, right, C prime, D prime, E prime, it would look like this. There we go. So one of the things to note is when you do this using instructions, I recommend that when you create your first circle right here on line M, that when you create your second one, use the compass tool itself to ensure that your second circle has the same radius as the first circle. Okay? And if you notice, I intentionally slid up the second circle to where the outer edge of the circle, the edge of the circle, intersected point C here. As I did with the first one. The first one, you could have put your circle anywhere on that line. Okay? But your radius had to still be from wherever you were on the center of that line all right, wherever your center was on that line, to point C. Okay, because that point C had to be a point of reflection, has to be. All right, and then second circle had to be the same radius as well. So just toy with your tools until you get pretty much what I have. All right, and again, these two circles have to be the same radius. Okay, and if you do it correctly, the point of intersection here lines up just nice, and these two images, when you connect the line segments or their sides, you can see it looks dead on. Looks like they're staring at each other in the mirror. All right, so instructions. This is a really important part. So write instructions how to reflect point P across the given line. So point P, I would say point P or point C? Let's see. No, it's point P. Okay. So if we had a point P, all right, I'm going to make that up. Here's our point P. Okay. What would we have to do? We would have to first construct a circle with the center on line M with a radius of M to P, right? So step one, we'd have to construct a circle. Forget there. Circle with a centered on line M, the radius of M, or I would say center M, right? MP, right? Now M, I'm just letting you know, is what I'm going to call the center right here. Or you can call it anything. I can call it centered on line M, label center. You could label it anything. We could label it B. Not taken. And make sure your circle has a distance of BP. Okay, like the oil company. All right, step two. So the center of that circle I created is called B, and then the radius has to be from B to P. All right, because we're reflecting point B. And then next thing you have to do is create our second circle, but this time it's got to be centered here, but the radius has to be from the center to P, just like with the other circle. Or actually, no, the first circle, right? So let's do that again. We need our second circle somewhere on line M, but it has to have the same radius as the first circle. So from here to here. And do you see how the points of intersection do not line up with point P? So I have to move our circle here until I get that intersection of point P. And the next point of intersection comes across here, and that will give us B prime. You can even test it with a line to see if it creates a perpendicular bisector. In this case, it does. So again, second step, construct a circle centered on line M. We'll label the center C, okay? And we have to have with a radius of BP. In this situation, it would be from C to P, right? But it has to have the same radius. Step three, right? Label points of intersection on those two circles. And last step, we would have to basically notice that the second point of intersection is P prime, right? It's the new image of P. And what I'm talking about is here's the original image of P, right? The pre-image, and now the image here is P prime. And you could always double check by seeing if it is actually a perpendicular bisector in reference to M, which it is. Okay, so make sure you know the tools there. Make sure you know the steps on how to do a reflection using constructions. Elena found C prime incorrectly. Ooh, what'd she do? Do you see it? E looks good, D looks good. She's convinced that C prime, D prime, E prime looks fine. Explain to Elena why C prime is not a reflection of C across line M. What would you tell Elena? Okay, go ahead and kind of think about that one real quick. I would probably ask Elena, I would probably ask her, does C does a line C prime create a perpendicular bisector? With line M. I would ask her that. I would probably ask her to construct one to double check, right? Usually with humans, it's good to take into account their ego. We all need ego to live, but at the same time, ego can get in the way. So I would usually use the Socratic method, ask questions, and eventually you're offering Elena an opportunity to double check her work, because everybody deserves a chance to learn, right? So just be aware of that. And you can tell, do these two images look the same? That's another question you could probably ask Elena, right? Does the pre-image look congruent to the image? Right? You could ask her that. That would probably help out as well. All right. And just like your left hand, right? Your left hand should look very similar to your right hand, right? Proportionality. All right, so again, summary, defining reflections. You have a point here, right? Point A, and we're going to reflect it across line L. If you notice, it's got to have a perpendicular bisector in order to successfully do that. If you were to construct a circle, you can do that real quick because we know the radius is the same all the way around it with circles, yeah? So if you to do this, you can actually construct a perpendicular bisector right away with just one circle, right? So we know 90 degrees here, and we know that distance from A to line L is the same as distance from A prime to line L. That's what these little markings here mean. All right, this means this distance is the same as this distance. Okay, so we define a reflection across line L as a transformation, so things are moving. It takes point A to point A prime, all right, and A prime lies on the line through A that is perpendicular to line L. Have to be perpendicular, 90 degrees. Okay, so that is the definition of your reflection. All right, have a beautiful day.